Get out your nose, please. How much money you have on you right now? Zero. No decimals, so like don't give me just change.
Okay, what if I have a check? Does that count?
5? 5? I got your 0. What? 5? 45? 40. That's good. Oh, go ahead. Okay. What? 175. Alright, that's good. You need yours on there?
Yeah.
What?
$1, and then I have some cents, but that doesn't count.
You don't have very much sense. Alright. Quiet, please. We're going to make a box plot, box and whisker plot with outliers, and go through how to find outliers, IQR, Q1, and stuff. You might want to, I'll give you a second actually. If you want to write this stuff down first, this is kind of like the definitions I'm going to use while we go through this. So I'll give you a minute if you want to write those down. And then we'll start making a box plot with that data. Talk about a few other things along the way. And have a rocking good time.
Should that be in parentheses for the outliers?
Where?
For the 1.5 times IQR? Or
What?
QP plus 1.5?
You want parentheses there?
Yeah. Like, should it be?
Hey, whatever, we'll change it.
It wouldn't? No.
What do parentheses mean? I mean, the multiply, right?
No, you put it on the side so that 1.5 is multiplied by 1 QR, right?
Yeah.
So then you add the order 3. But
So there's also this thing called the order of operations.
I know, but
You can write it if you like.
because
The rest of us have more sense.
you're so mean to me. I'm at this class. You're gonna be the reason
Whatever.
why I dropped out of high
I'm like your
school.
favorite.
My senior year. Kendall says hi, by the way.
Who?
Kendall Martinez. The city of get this year.
Kendall Martinez?
I know him.
Short Mexican.
I don't.
Does he go by something else?
No.
No, his name's Kendall. He's very short.
What grade is he in?
And he is a Muslim.
first letter. Yeah, leave one. What's last name? Okay. So, if we're going to find, we got to start finding like median. And that's basically the first thing we find is median. So what's the first thing we have to do with the numbers then? Put them in order from low to high, right? So, some of you might have already done that, I don't know. But we got 1, 2, 4 zeros. We got a 1, 2, 5, 5, 5. So you already did this, huh, Drew?
Yeah, a 9.
9. There's a big gap there. No one has like 15 on
40s,
40, 40.
74, and 79.
You said this is boxplots, right?
Yeah, if you want a title, we're doing bots. I forget titles all the time. I'm sorry. But just yell at me and I'll give you a title. 74, 79. And then 175, 218. All right, there's 17 numbers. And, I mean, to find the median, we can just start chopping off from both sides, right? Like, that will work. But, the AP test will give you some where there's like 700 numbers. And I'm not going to write them all down in order and start chopping off. So, I'd like to find a shorter way to do if there's a big group of numbers. So, let's just start kind of making a list. I'm going to do odds and evens separately. I'm going to come back to this. Let's look at odds. If there were 3 numbers in your data set, it's like A, B, C, which number in the list would be your median? The second one, right? I know I said A, B, C, that was weird. But so if I had 1, 2, 3, the second one would be your median. If I had 5 in my list, 1, 2, 3, 4, 5, which one's the median? Third one. If I had 7, which one's the median? 1, 2, 3, 4, 5, 6, 7, right? The fourth one. So we have 17. Take a second and figure out which one's the median there. If this is this easy for you guys to see over here?
Oh, yeah, thank you.
You got like your own little TV there. So if I have 17, which one is the median?
5.
No, like not like which one in the list? Be the 9th,
Yes,
right?
the 9th, but it'll be numbered.
Right. But I'm just looking at the number of the list right now.
Okay.
What if I had n? Don't say it out loud yet. Just give everyone a chance to kind of think about it. If I said there's n numbers, which number in the list is the median? Don't say it out loud yet. Like, what's the pattern? How do I get from this number to this number on every one of these? So what you're doing is just adding 1 to this and then cutting it in half, right? Like 7 plus 1 is 8. 8 divided by 2 is 4. 17 plus 1 is 18. Divided by 2 gives you 9. So it's always add 1 and then cut it in half. So if I wanted the median here, it would be the 9th number in the list. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one here is going to be our median, which we'll kind of come back to that in a second. What if I have an even number in my data set? Like if I have 4 numbers, let's say it was 1, 2, 3, 4. It's a little bit goofy here. Could you have a question or you were going to answer something? Okay. Well, thank you. So I would take like between the second and third number, right? Because you cut off the 1, the 4, and then you'd be like, okay, I'm going to take the average of those. I'm going to call that the 2.5th number. I'm not sure that's like technically the way you would say it, but just so we're all on the same page. If I had 6, what would the median be? Like the 3.5th number, right? If I had 10, take a second. What would the median be? It'd be 5.5. So then again, this is what I want really. If I had n numbers in my data set, where's the median? same thing, right? It's still n plus 1 over 2. So some people think even odds are different, and they are a little bit, because you got that average thing going on, or you're just taking a number. But your general pattern is the same. And here's why that matters. Here's what the AP test will do. They'll give you a question like this. And they'll say, here were the AP stats scores last year. They'll say there were 100 ones, 105 twos, 150 threes, 201 fours, and 50 fives. What's the median? So take a second and you can kind of tell by looking, I guess, but take a second and figure out, like, to know for sure that you're not just like eyeballing it and look. How would you find the actual median right there? Don't say it out loud. Don't eyeball, that's cheating. So I'm going to add up all the data points. So 100, this is 205, 365, 566, so 616. I'm going to add 1 and cut it in half. So it'll be 617 divided by 2, so 308.5. So I would want to find the 308th data point and the 309th data point. And average them together, so I want to know where those are. Well, the first 100 are here. By the time I get to here, I've got 205. So wouldn't the 308th and 309th be in this bar? They'd both be 3s, so the median would be 3. And again, you can tell by eyeballing, but does that make sense what I'm actually doing to find it out? This is very commonly the first question on the AP test. It's like a basic concept, right? Like median's not something, I mean, probably just like 6th or 7th grade, but they're giving you like a much more difficult look at it, I guess. What's up?
It's 606.
Oh, is it? So this is 303.5. It's the same answer though, right? But yeah, I should probably know how to do math, I guess. Might be. Does that idea make sense though? Okay. Alright, let's go back to so this is our median. So this is an odd number of data points. So right now I can go down below this, right? Okay, that's the median, which is also known as Q2. That's the second quarter of the data. Because I had an odd number and my median was an actual data point, when I go to look at the median of the bottom half and the top half, this number is not in the game anymore. I crossed it out. That number has already been used. It's the median. So now I'm going to find the median of the bottom half, but that number that I just found isn't in the bottom half. It's not the top half either. So I had 17 numbers. I just knocked one out. So how many numbers do I have left? 16. Bottom half, how many are going to be there? 8. So which numbers, where do I get the median from? 8 plus 1 is 9 divided by 2, so the 4.5, so the 4th and 5th numbers. Which, I mean, if you can cross off 2. I'm just trying to get you thinking more like big picture stuff. So the 4th number is a 0, the 5th number is a 5, or if you crossed off, you get the same thing. And your Q1 would be 0.5, because you would take the average of those. Same thing on the top. I want like the 4th and 5th data set past the median, so going this way. Or you can come in from the end if you want, or you can chop. So we're going to get 40 and 74, so the average of those two is 100. So 100, what was that, 37? No, 50. can start our box plot. I'm going to put 0.5 here, and that's my Q1. 57 here, and that's my Q3. And it doesn't have to be to scale, but make it like reasonably to scale. The median's 5, right? Don't put 5 in the middle. Like 5 is not halfway between 0.5 and 57. So put it somewhere over here, closer to Q1. The median is also Q2. You can call that either thing you want. And they're called Q1, Q2. It's the first, second, third quartiles. So what we just did is chop the data into 4 parts, quartiles. And it doesn't work perfectly in a small data set like this, but in general, 25% of the data is here, 25% of the data is here, 25% of the data is here, and 25% of the data is there. You're splitting it up into 4 parts where they all have the same amount of data. So it's the median, cuts in half, and then the median of that cuts that part in half, and you got these 4 equal parts. You know, with 17 numbers, it doesn't divide by 4 evenly. It's not going to be like perfect, but that's the general idea. So another, very possible AP question. What percent of the data is between 0.5 and 57? 50%. So 0.5 is here, 57 is here. There are 2 like quartiles between those. That's 50%. What percent of the data is below 57? 75%. Because you're just going, okay, 25%, 25%, 25%. Okay, questions on, just get to that part. Okay, so the next thing is to worry about if there's outliers or not, and put the whiskers. The whiskers are like the little line. There's like a, do you know what I mean by whiskers? So we're gonna find the IQR. The IQR is this distance. IQR is the inner quartile range. So there's 4 quartiles, right? The 2 in the middle, the 2 on the inside, the inner ones. That's IQR. And that's just going to be Q3 minus Q1. So in this case, it's 57 minus 0.5, or 56.5. And again, that's half the data. 50% of the data, because that's 2 quartiles, is between 0.5 and 57. Outliers are things that they consider like, okay, this is far